Hello, welcome once again. We're going to go over the relay again because I got some comments that it was confusing, the videos that I made, and I'll try to clear things up. This pictorial over here demonstrates the insides of the relay. Hopefully it'll help. You always have the battery, obviously the positive. This is the coil. Now, when you have current flowing through it, you have a magnetic field around it. You have one part of this relay. You have the other part called the contact points over here. This is the armature. From the 12 volts over here, you have current flowing through this coil over here. And then it comes out and back to ground. In this specific circuit, we have a horn. We're trying to get the horns to blow through this relay. Now, so we have, this is called obviously the control side of it, and it's called the load side of it. The load usually means it goes to the load. In this case, the horn. The load could be the fuel pump. The load could be the starter motor. The load could be the lights. It could be anything. So in this case, usually we're trying to control a low current with a very high current, two circuits. So current flows through here and to ground. You notice this ground over here is mechanical. We're the ones who's pressing the button to switch. We said before, always be aware because it can also be a computer closing the ground. So we have one part of the equation so far. Current flowing through this one, fine. Now when this gets an electromagnetic field, it closes these contacts. What does that allow us to do? It allows us now to make a connection from the B plus to the loads that we want to activate. In this case, obviously, two horns. So current flows from B plus through the armature over here, through these contacts. Remember, now these are closed. Why? Because this has current flowing through it. This electromagnetic field closed these contact points. Great. So now current can flow this, which is closed, come out at H and make these horns blow under the condition that we're pressing this button. So again, we're going into B, we're coming out S for this one, we're going into B this one, and we're coming out H into this one. So my theory is, and I know it's been confusing, instead of the control circuit here, calling it a control circuit, instead of calling this the load side, I want to call this the input. I want to call this the output. If I know there's an output or 12 volts here, doesn't that mean that I had an input? Yes. This is what I'm doing when I'm using my technique for measuring the relays. So I'm going to decide, I'm going to look where the load is, the closest point I can to the load. In this case, obviously, it's H, terminal H. Now I'm going to measure over there. Now, with that theory, what is that going to tell me? That's going to tell me that the contact points are closed. Why are the contact points closed? Because this coil had a magnetic field. And what caused the magnetic field? Current flowing through it. And where did the current flowing through it came from? The battery, through B. That means this is working. That means B plus is working. If there would be a fuse here, that means the fuse is good. So what am I trying to convey? In one shot, I can see that H tells me that the relay is on, because these are connected together. That means that this is doing its job, creating a magnetic field from the coil, from the current going through it. Let's take that concept. Now, there are many ways how to do this, and I'll show you in the schematic, but of course, there's some ways you could take out the relay, and then I'm going to go over here, measure 12 volts over here, or maybe 12 volts over here, take out the relay, or jump the relay. Where am I going to jump? I'm going to jump from here to here, or over the contact points. Is my method the only one? No, it's not the only one. Can you do it another way? Yes, you can. Of course, you can jump these two. Yes, you can. But I'm trying to avoid the error of maybe somebody jumping, instead of these two, he'll jump these two, and this is the resistance in the current in the circuit. That's not a good thing, because then you have computers, obviously, which will take the grunt or the blow of it when you jump these two. Basically, you're jumping ground to B plus when you're jumping these two. So anyway, that's one way of doing it. Other way is obviously to go here and measure 12 volts and measure ground here, measure 12 volts with a power probe. If you measure at H 12 volts in one shot, that tells me input is working and the output is working. Let's go to the example that I've been using in the schematic, and hopefully it'll be a little more clearer now. We took this schematic over here. This is for a starter mode that we're going over. The starter over here is the same idea applies. Current goes through this coil. Once current goes over here, and we call it the control circuit. I call it the input. This switch, which is in this position now, is being pulled in. So these two contacts are making contact. So 1 and 2 on the schematic is represented by these contact points, which is closed. So now we know that this switch is flipped. What does that tell me? That tells me that this starter relay is activated. So that tells me in general the relay is working. So where am I going to go to measure? I'm going to go right here. I put number 1 over here. In respect to this point, then I'm going to measure 12 volts. Why? If this is 12 volts, that tells me this switch flipped from this position to this position. Why is it 12 volts? Because now this is 12 volts. Why did it flip to this position from here to here? Why? What caused that? He caused it. You see this dotted line? See this dotted line? That means when I'm activated, I will activate you. I will take you together with me. We're in this together, right? So therefore, when this is working, and I get 12 volts. I know the whole relay is working. That means I'm connected to 12 volts. That means that this got 12 volts. How do I know that? That means the switch, our ignition switch, is correct. It's in the start position. If this switch would be in the accessories position, would I get 12 volts here? No. There's no connection to accessory. There's no connection to on. Where do you see a line here? Only in the start position. Therefore, the black and white wire over here, this is pin 1, goes into this connector 3, right? By this telling me 12 volts, I know this is good. The ignition switch is good. Otherwise, I wouldn't have 12 volts. But didn't I know that when I measure 12 volts over here? Yes. I'm doing all this in one shot going over here. Now you're going to ask the question, but how am I going to measure inside a relay? Well, if you remember the video that I just shot and I showed you how to measure internal in the relay with a piece of wire, for starter motor relay, for fuel pump relay, I showed you those 2 videos. Go to those videos and you'll see the technique. So I measure 12 volts over here. I'm good. Everything over here. Now what are we left with? Let's zoom out. We focused on this. Let's zoom out. Went over here. Now we're just left with starter motor. Why did I start over here? Where's the load? This is the load, the starter motor. We try to get as close as we can to the load. For the obvious reasons. This is underneath the vehicle, hard to get to. Number 1. Number 2, I want to try to get to the load as much as I can because I want to see if all this circuit is working. The fact that I got 12 volts in this point, measuring this point, instead of jumping a relay, instead of taking a power probe, it told me this relay is working. It told me this is connected to ground. How? How is this connected to ground? Through this switch, right? The park neutral safety switch. When I connected either in park or neutral, guess where I'm connected to? I'm connecting this part of the coil of the relay. I'm connecting pin 4 or terminal 4 to ground. That's good enough. That now I have a current able to flow to ground. Now he's going to do his part. He's going to flip from here to here. That tells me all of this is working. That tells me, if I zoom out, All of this is working. That tells me the multi-fuse is good because current is flow. Remember current. That's why I teach current. Current needs a complete path. Where are you going to find a complete path? From here, here, to ground. That's the complete path. The fact that I have 12 here and 0 here tells me this is grounded. Now this can conduct current through it. That's why I choose this point, 12 volts. In one shot, it told me all these components are good. That tells me that where's the problem? I have 12 volts here. Then I have to worry about this problem over here, going to the solenoid, to the starter motor. But that's beneath the car. This is why I choose to do it. This technique, like I showed you, works for a fuel pump relay, starter motor relay, light control module relay, any relay. It works for anything. Once I know I have 12 volts here, I know this is good. I know he's good. I know this switch is good in this schematic. I know this switch is good. I know fuse is good. I know this fuse is good. I know the battery is good. In one shot. Let's make believe I didn't get 12 volts. I got 0 volts. Where am I going to go my next point? I put a 1 over here. This is number 1. My next point I'm going to go to is 2 over here. Then I'm going to go to 3. Then I'm going to go to this one. We have 0 volts over here. Uh-oh. Did he move? Did this switch move? Did the contacts close? Let's see. 0 volts here tells me, well, maybe you're going to say, okay, maybe I don't have 12 volts over here, right? And that's why I have 0 volts. It's a possibility. We can respond to that argument by going over here and saying, okay, let's go to 12 volts over here. If I have 12 volts over here, guess what? That means this person should be activated as long as there's a ground for him through this switch. That's why I go 1 here, number 1, priority. Number 2, I go here. If I have 12 volts over here, that means all of this is good. That means somehow the problem isn't here. But 12 volts tells me also all this is good, but I need a ground. See? I can still have 12 volts over here regardless of this relay. If you pull this relay out, that's why I don't like that technique. 12 volts just tells me all this is good. The switch is good, the fuses are good, and I have 12 volts. Fine. Fine. Now, but I still need a ground. Don't I need a ground? We just said that. I just need a ground through the switch. So therefore, when I measure my third point over here, after I measure 12 volts over here, fine. Now everything is good. Is this conducting? How will I know? How will I know? When I put the gear shift in park or neutral, and I measure 0 volts here. That means the input is good. He's the blame over here. The relay is the problem. This is why I choose this point. Again, it's not the only technique. You can also, like I said, you could go to every single point and measure every single. You could take out the relay, take your power probe, and say, okay, I measure 12 volts here. I measure 12 volts over here. Good. So the problem could be the relay. You still have to take out the relay and test it, don't you? With this technique, this is being tested in the circuit. That's all the knowledge that I need. 12 volts here, 0 volts here, tells me this part of the circuit is not good. Correct? That's why I choose this one. I hope this was a little better understanding than before. Okay, if you have any questions, just leave comments. Anyway, I'd like to thank the people that I got monetized. It was a great accomplishment. Thank you for all the comments. Thank you for all the support you've been giving me. I hope to improve the quality of these videos. I hope to improve the quality of the channel. Hopefully now I have more privileges as I got monetized. A great achievement in my life. Thank you to all the viewers. Thank you so much. Anyway, hope to give better quality and improve quality. Definitely. Thank you.